Hello YouTube! Welcome to another tutorial brought to you by XL-lence. Today we're going to be looking at the index and match functions. In this tutorial we will look at how we can combine these two functions and use them in a similar way to the VLookup function. You may be wondering, if it's similar to the VLookup function, then why would I want to use this method? Well, the concept is similar, but using the index and match functions together helps create a more dynamic and powerful function that is far superior to the VLookup and HLookup functions. Since this tutorial is based around the VLookup concept, if you are unsure of what it is, then I suggest that you take a minute to check out either of my videos below. So let's get started. Individually these functions are very basic, but combining them into one long function can be tricky. So I think that we should start by looking at each of the functions separately, and then we will look at how they can be combined to give the desired result. Firstly, the index function. This allows the user to get the value of a cell by stating what row and column number it is in. If we have a range of data such as this, and we want the value in the 5th row and 3rd column, then we would use the index function. Alright, so let's take a look at the arguments in the index function by opening the formula window. To do this, we will go to Formulas, Lookup and Reference, and we will select Index. As you see, there are two options available to us. We will select the top one. When the dialog box opens, you will see that we have a brief explanation of the function. It states that the function returns a value or reference of the cell at the intersection of a particular row and column in a given range. The first argument is array. This is the range that contains the desired value. In our example, we will select this entire range here. The second and third arguments are simply the row number and column number of the desired result. We will enter 5 and 3 respectively. And clicking OK shows that we get the correct answer. To use this function as is, the user needs to enter the row number and column number, which in most cases is not much use. That's where the match function comes in. The match function will return the position of a value in a range. So here in this list of names, if we wanted to return the position of John Doe, then we would get 5, as it is the 5th name on the list. For this to work, the range needs to be a one-dimensional range. This means that it must be either one column across or one row down. So to look at the arguments in the match function, we will again open the formula window. The explanation here says that the function returns the relative position of an item in an array that matches a specified value in a specified order. The first argument is the lookup value. This is the value that you are looking for in the range and want to find the position of. In our example, it is John Doe. This can either be a typed value or a cell value. Next we have the lookup array. This is the one-dimensional range that we will search in for the lookup value. In our example, it is this range. And finally, we have an optional field. There are 3 options for this field that correlate to whether or not the range is in ascending order, in a random order, or in descending order, and can be selected using 1, 0, or -1 respectively. This is very similar to the range lookup option in the VLookup function. I will go into this in more detail later, but for now it's safe to say that you will almost always want an exact match and use 0. A key thing to note here is that although this is an optional field, you will need to put 0 because Excel assumes that if it's blank then your range is in ascending order. Since we are looking for a name and our list isn't in order, we will put 0. And there we have it. The name John Doe is the 5th name on the list. So how exactly does this help us with the index function? Well, now we can use the match function to determine what the row and column numbers are. Okay, so let's try it out using this example. In column K we have last week's top sellers for each type of fruit and how many crates were sold in column L. What we want is to check how many they sold this week using the index match function. Let's start with this first person. And of course the index function goes first, so equals index open bracket. The first argument is the array. Remember that this is the range that contains our desired result, so we will select this range. Be careful to only select the numbers and not the names or the fruit at the top. I will discuss why this is important shortly. We will then press F4 to fix this range. The next argument is the row number. This is where we will use the match function. So we enter match, open bracket. The first argument in the match function is the name. So we will select Danny Banks. Next we have the lookup array. This is the one-dimensional range that contains the name we are looking for. It is this list of names here. We need to make sure that the length and position of this list matches our index range. And once again we will press F4 to fix the range. Finally, the match type. As I mentioned earlier, we will almost always want an exact match, so we enter 0, close bracket. That will now give us the position of Danny Banks in that list. Now for the column. We will once again use the match function, so match, open bracket, the lookup value is the fruit, which is apple in this case. The lookup array is the horizontal list of the fruit at the top here. The width and position also needs to match the index range, and as before, for the match type we will enter 0 to get an exact match. Close bracket. This will now give us the position of apple in the list of fruit. That is all the arguments in the index function, so we will add another close bracket and press enter. And there we have it. Danny Banks sold 10 crates of apples this week. We can then apply this equation to the rest of the people. As you can see that by using the match function inside of the index function, we can easily create a dynamic lookup function that works in 2 dimensions. If you were to try this with the VLookup and HLookup function, it would be a lot more complicated. Now I just want to quickly discuss the importance of matching the index range with the match range. If we jump back into the equation, we will see that the ranges line up. This is important because the match function only returns the position of the name in that one-dimensional list. It has no reference to where the index range is. If, for example, instead of selecting just the list of names, I selected the title at the top, then we would get an incorrect result. The match function that is returning the row searches the list for the name Danny Banks and finds it in the 14th row down in that particular range. It then passes its value to the index function, which tells the index function that it should take the value that is in the 14th row. However, since they are not aligned, the 14th row down is actually incorrect and it should be the 13th row. When I entered the equation, I specifically said that for the index range, we will only select the numbers and not select the names of the sellers or fruit. This was to ensure the ranges were aligned. You could in fact have selected the entire table and still align the ranges by overlapping the ranges. The match range for the names and fruit would be as such, and the index range would be this entire range here. We have also only looked at 2-dimensional examples and used the match function for both the row and column number, but it is possible to simplify the equation and use it like a VLookup or HLookup function. Let's say that we only wanted to get the total number of fruit sold. We could use our previous method of using the match function to determine both the row and the column number, but in this case we know that we are only going to be looking in the totals column and can therefore simplify our equation. Instead of selecting the entire range, we will only select the total column. This means that we will no longer need to use the match function to get the correct column. So we would type index open bracket. As I said, the array will simply be this range in the total column. For the row number, we will still use the match function, so match open bracket. The value that we want to search for is this name. We will be looking in this list of names and making sure that it lines up with the index range. And of course, we want an exact match, so 0 and close bracket. Now you'll see that if we look at the formula dialog box that appears when entering an equation, you'll see that the column number is actually in square brackets, which indicates that this is an optional field, and hence we can leave it blank. We could type in 1, as it is column number 1, but it is not necessary. So close bracket and enter. This gives us the correct total value for Brad George. Because of the way that the index function uses the match function to calculate the row or column number, it enables a feature that sets it apart from the VLookup and HLookup function. The VLookup only allows you to work in one direction, left to right, and HLookup only allows you to work from top to bottom. But with the index match functions, you're able to do what is essentially a backwards lookup. Let me explain with this example. Here we have a table similar to the previous example, but with a lot more fruit. Using the large and small functions, I've determined the 3 most popular fruit and the 3 least popular fruit. However, without manually looking for them in the table, we don't know what they are. So what we want is to obtain the names of the fruit that these totals correlate to. Since the totals are at the bottom of the table, we are unable to use the HLookup function, as that only works top to bottom. However, with the index match functions, we can look in any direction that we want. So we would enter index, open bracket. Remember that we are doing almost like a reverse lookup. So we want a fruit for the final result. The index range is therefore the horizontal list of fruit at the top of the page. Now for the row. We know that the row is going to be 1 as our index range is only 1 row high. Although we don't need to enter the match function, we still need to enter 1 as this is not an optional field. Now for the column number. This is where we will enter the match function. So match, open bracket, the value that we want to search for is this number here from the totals at the bottom of the page. Since these numbers aren't in order, we need to put 0 to indicate that we want an exact match. Close bracket for the match function, another close bracket for the index function, and enter. There we have it, the strawberry is the most popular fruit. We can then just copy and paste this to the other items. One thing to note here is that if we had multiple fruit with the same totals, then this would not work. And just before we finish up, I want to quickly discuss the last argument in the match function, the match type. As I mentioned earlier, this is used to indicate whether the list is in ascending order, descending order, or not sorted at all. If you have seen my VLookup and HLookup video, then you will know the concept of this, as it is the same as the range lookup value in those functions. I would say that 99% of the time you will be using 0 because you need an exact match, but the other options can be useful, so let's take a look at how they work. In this example, we will be purely looking at the match function, but it can just as easily be put into the index function as we did previously. This example tries to determine the grade that each individual receives based on their grades. Since the grade table does not contain every number, we cannot use the exact match. Okay, so there are 3 options for the match type. The first is 1, less than. If we look at the dialog box that appears, it says that this will find the largest value that is less than or equal to the value that we are searching for, and that the list must be in ascending order. Excel is doing something a little more complex, but the simplest way to view this is as follows. The function is going through the list until it reaches the value that is higher than the value that we are looking for, and then taking the previous result, which is 4. The third option for the match type is -1, greater than. The dialog box says that this will find the smallest value that is greater than or equal to our value, and that the list must be in descending order. This is essentially the reverse of the first option. The simplest way to think of this is to assume that with the list in descending order, the function starts at the bottom of the list, makes its way up until it finds a value that is greater than the value that we are looking for, and returns the position. These are great when you have a range such as these test scores or when using dates. Another great use for the 1 and -1 option is when you want to use a dynamic range in your formula. That's probably it for today, so just to recap, By combining the index and match functions, we are able to simulate a VLookup and HLookup formula that is more dynamic and powerful, as we can search in 2 dimensions as well as work backwards in our table. Although this method is better in many ways, it does not mean that the VLookup and HLookup functions become obsolete. In most cases, when I need to do a simple VLookup, I still use the VLookup function, as it is much easier and quicker to use. If you have any other questions or anything else that you would like me to do a tutorial on, let me know by leaving a comment below. Also, don't forget to like and subscribe. Thanks for watching.